afternoon. We are back at episode 2 of Math Monday for Cognition of Davie. My name is Peter, and today we will be continuing with our activity that we began last Monday. Last Monday, you may recall that we made paper rockets, not only because it was fun and math could be fun, but also and primarily so we could collect some data that then we were going to use over the next several weeks in order to really work on some real math concepts, which is going to be landmarks in data. So last week, you built your rocket and you collected data on this sheet here. And I've still got my sheet, and I hope you've still got yours too. Now, with content like this, it not being for a specific age of child or a specific grade level, I'm going to divide up the difficulty and the challenge level of the math that we're going to do in a slightly different way. Instead of saying this is second grade, or this is fifth grade, or this is ninth grade, instead I'm going to grade this according to the hotness of various chili peppers. This is a bit of a novel way to do it, but it also allows you to kind of differentiate for yourselves for whatever level of spiciness is quite right for you. So, if you did not know, the hotness of chili peppers is measured on a scale called the Scoville scale. The Scoville scale is a measure of the concentration of the active chemical in the chili pepper, capsaicin. Chili peppers go all the way from 0 on the Scoville scale, which is a bell pepper, all the way up to the very hottest pepper currently on record with Guinness, which is the aptly named Carolina Reaper. There are lots of peppers in between, of course. So, today's math that we're going to do is going to be bell pepper level. It is not at all spicy. It is accessible to everyone. Next week, we're going to move into poblano. The week after, jalapeno, followed by the famous and very hot habanero, and finally, finish up with mean absolute deviation, sometimes abbreviated MAD, with the record-holding Carolina Reaper pepper. So, let's get started on our actual math. All right, by now you've gathered your rocket data from last week, and today we are going to focus on minimum, maximum, and range, bell pepper level skills accessible to all mathematicians. So, I'm looking at my data that I collected for rocket number 1, and for minimum, that is just the way it sounds. Minimum means the smallest, or the smallest amount. So I'm going to look through my data and pick the smallest number, which in this case is the number of steps that my shortest rocket flight traveled. So in this case, for me, it was trial number 5 here with 8 steps. So I'll mark that with an M here. That was my minimum. And then next I'm going to pick my maximum, or my largest number out of the data set. Let's see, 11, 12, 13, 14. My last rocket flight was 14 steps. That was my maximum flight. I'll take a moment and write these numbers down here in my landmarks. My minimum was 8. My maximum was 14. Finally, in order to find the range, the last landmark we're going to look at today, I'm going to find the difference between the minimum and the maximum. You will know that difference is another word for subtraction. So I'm going to need to subtract the minimum from the maximum. If I was writing out that subtraction problem, I would have the maximum on top and the minimum on the bottom. That's the way it would look. It looks here like I cannot actually take an 8 from a 4. I'm going to need to borrow. So I look one place to the left. I can borrow a group of 10 from the 1. I'll cross it out, make it a 0, and add my group of 10 to the 4, making it 14. At this point, I will go ahead and subtract. 14 minus 8 is 6. So my range for this data set was 6, the distance or the difference between the maximum and the minimum. So those are the 3 landmarks that we are looking at for today. Now, I can calculate this for my second rocket as well. So my minimum will be the smallest flight here, or the shortest flight. It looks like it was probably 13. My maximum or longest flight was 19. Again, trial number 10. and my range, the difference between 13 and 19 is 6. Now, that math may seem fairly basic, and indeed in some respects it is. However, some of you may have collected data that is composed that has decimals or fractions in it. If that is the case, this process of subtraction, finding the range of your data, could be a good deal more challenging. If perhaps you are a young mathematician sitting out there thinking that this is far and vastly beneath you with your whole number data, you could go ahead and collect some new data that has decimals or fractions in it. It wouldn't take you very long, and then you'll have a much higher level of challenge finding the range for this week. Now, though these are basic skills, you're not going to learn them solidly unless you actually practice. Math is not hard, but it does require effort and practice to be good at, just like any other skill. So, I would advise you, see if you can collect some more data on something different and practice finding the minimum, maximum, and range several more times. Research on math suggests that the minimum amount of times you're going to need to practice something in order to learn it solidly is 4, and that it may take even up to 20 practice sessions before you are proficient with a new skill. So you could find the weights of various fruits or vegetables in your kitchen. You could count the number of branches on the 3 or 4 different closest trees to your front door. You could go ahead and calculate and then find the minimum, maximum, and range for the ages of the people in your household. And if you want to make it more challenging, find their ages in months or weeks instead of using years. So there are lots of ways that you could practice and lots of data sets that you have access to right in your own home. Today, we learned a little bit about minimum, maximum, and range, and you have a way to collect data involving shooting your rocket, but not at your brother's face. And you have some other ways you could collect data too, involving household objects, fruits in the kitchen, trees in the yard. So that was some bell pepper level math. The official Scoville rating, or the official amount of heat in a bell pepper, is 0. But next week, we're going to take a step up to the poblano pepper. A poblano pepper has an average Scoville heat rating of 1,000 to 1,500. You'll notice it's a range because, of course, not all peppers are the same. However, it is a pepper that is still going to be accessible to almost everyone, and I'm looking forward to seeing you next week as we learn about mode and median. Goodbye for now.